Yep.
There'll never be a time.
All right, let's get started. Today, I want to be mostly a question and answer session for you, since Wednesday is the next exam. You should have seen earlier today, I posted an example exam that you can use to help prepare, like the previous two tests. And so I'm just going to open it up for questions from you guys. I don't know that I'll be able to go through all the example questions, so but I'll do the best I can based on the questions that you have. So what kind of questions do you guys have? Yes, Chris.
What do most students get wrong in science?
I don't know. What do most students get wrong? I probably should look at it to try to figure out. It's been a year since I last looked at it. I'd have to think about that. So on this first page, some students didn't know what LP meant, which is linear program. So that was problematic. Makes it hard to answer the questions when I ask, then what does it mean? But most of the people who did then were able to say that the LP relaxation is where you ignore the integer constraints. And so you solve it as if it isn't an integer problem. Of course, it doesn't necessarily give you a value that's meaningful. If you really need those integer constraints, you probably need those integer constraints. But we can solve that optimally and maybe make an estimation of what a final solution needs to look like. In this second problem, most people got this one. It's just a matter of looking at these things and saying, can you use fractional components? So for this one, first one, pounds of TNT, yeah, I can have a half a pound of TNT or a third of a pound of TNT. So that doesn't make sense to make an integer constraint. But if we take the next one, rounds of ammunition, yeah, I can't use a half of a bullet. That doesn't work too well, right? So, so you just have to use really common sense as you go through these 6 ones and say, can you use a partial one of these? So, yes, no, no, yes, no, no, right? For partial. So this is not integer, this is integer. This is integer, this is not integer, integer, right? Because you don't ship half of a food, or but you can ship half of a gallon of water, for instance. And so that's a real easy way that you can ask and answer this question, whether it's an integer makes sense, is can you have part of one of these units? Here. I will have to update this. This was a little bit wonky here, so I'll probably give you a different decision tree than this. But most people were able to get the estimated value out of here. Some people had a little bit of difficulty trying to translate this decision tree into some sort of English description. But it should be, you're trying to choose a location, right, whether it's on the west coast or the east coast. And then you're also trying to choose what building size you're going to build. So you're making two choices in this example here, where to place it and what size to do. And then, and this is where it's a little bit wonky. This probably should have been not small, medium, large, but maybe demand. It would have been a little bit easier, high demand, medium demand, and low demand, or something like that. So it was a little bit confusing there, but based on where you did it and what size you did it, you would have these different likelihoods of profit or something like that. So what I was looking for is that you could represent these percentages, that you'd say that there's a 30% probability that you'd make this, 70% probability you'd make that, and so the wording made it a little bit confusing. I will tighten it up for the next exam here. So that made it a little bit hard for question part B. Yes.
So the numbers on the right hand side, those are the profit numbers?
Right, that's how much you would make given given that particular state of nature. Right. So if you ended up here, you would expect to make $35, versus if you ended up here, you'd expect to make $75. And then these are probabilities that each one of those would happen. So these actually, I used the wrong wording, these are not decisions that are being made, right? Because you don't have a probability on a decision. These are probabilities that these states of nature would occur. So a decision was made over here, and these are the probability that things that are outside of your control would happen. That's the only reason you would put probabilities in there. Because if they were within your control, then you wouldn't put a probability next to it. You say, I'm going to do this, or I'm not going to do this. Okay, so like I said, it was a little bit confusing, so this one was a little bit difficult because of that. And I will tighten it up for it.
Will the numbers ever be the cost?
They could be. So in this one, I would allow you to say cost or profit because it's not written here what that would be. What I wanted to see is that you understood how these probabilities related to each other, how these probabilities related to each other, and that they were choices outside of your control. Yes?
What would for part A, the equation for the expected value look like?
So then you would do, let me write it down on the board here. You would have 30% times whatever the cost is for the upper part plus 70% times whatever the cost is on the lower part. And then repeatedly, the cost in the upper part would be, these percentages are going here, right? Right here, be 20% times 20 plus 30% times 45 plus 30% times 75. And in here, you would get 25% times 5 plus 60% times 35 plus 15% times 95. And because, again, no calculators, I would allow you to just leave it at that. You wouldn't have to figure out the exact, what the final value is if you're showing the percentages times each of their individual values. I'm not looking for whatever this ends up resulting in. I want to see the equation and how you get to that final, how you would compute the value rather than what the actual value is. That's more important. Yeah.
would that be, where it says 30% times 45, would that be 30 or 50?
30% times,
No, the very top. Yeah.
oh, that's 50%, I've been reading poorly, thank you. Alright, so this was a little bit problematic, and so I'll tighten that up more. This one, yeah, there was definitely more variability in here. If you didn't understand how to do the different mutual exclusion, co-requisite, K of n, those different types of solutions, then this became difficult because trying to come up with them on the spot was tough. The other thing that was new here is that oftentimes it took more than just one constraint to get what the question was asking for. So as an example here in C, it says write a set of constraints that cause 1, 4, and 9 to always be selected together. Okay, you cannot do that with a single constraint because we need a transitive behavior. If I just said that ensures 1 and 4 are always selected together, then we could do it with a single constraint, right? That would be x1 equals x4. And so then we want another one that's x4 equals x9. So if you have those two constraints, then you have everything you need to get them all three to be selected at the same time. Some people also added x1 equals x9. That's not strictly necessary because if x1 is equal to x4 and x4 is equal to x9, then by transitive that this is also becomes true. So this is what was necessary to accomplish. So in some of these, here's another one. You actually have to combine multiple constraints together to get what the English description is requiring from you. So in this case, you're going to use one that gets the at least 2, and you're going to use a second one that gives you no more than 5. And the combination of those two constraints gets you that full English description. And so if you know how to make each of those individual pieces, putting them together becomes hopefully pretty straightforward. But if you don't know each of those individual pieces, then combining them together is really, really difficult because you didn't know the parts to make up the whole. All right. And notice that sometimes I'll give you an English description and you have to give me the constraints. Sometimes I'll give you the constraint and you have to tell me what that English description means. So for that first one, what does 3 times x plus x3, x7, or plus x8 is less than or equal to 3 mean? Does anyone see what that means? Yeah.
It means that if you have x1, then it can only be x1. But if you don't choose that, then you can choose the other ones or less than the other ones.
Right. So we're combining an exclusive OR in here, right? It's either x1 or some combination of, what is that, 3, 7, and 8? And it doesn't have to be all 3 of these, right? Because it says less than or equal to 3. So x1 does not allow you to do any one of these 3, but if you can have any combination of these 3 going right here, right? So you have to kind of think through what this mathematical equation is actually saying. Yes.
Can you do the constraints for part B?
for part B. So how would we do at least 2? How would we do at least 2? Yeah.
The sum of the x's are greater than or equal to.
Okay. So that would be our first constraint. How would we do no more than 5? Sum of the x's are
Less than or equal to 5.
less than or equal to 5. So that's those 2 constraints. And remember, this is just one sum equation. So this is 2 equations. This is 2.
So do you have to move into the right hand side stuff? So for example, part C, we have like xi equals x, or do you have to make it xi minus x?
No, I'm not requiring you to do that. The software is capable of making that change, so I'm not going to make you do it. So make it so it makes the most sense to how you express it. So you can, if you want to, yeah, you could do xi minus xj equals 0, right? That's the same as xi equals xj. I'll accept both. Okay, so this one could be a little bit tricky here. Yes?
Can you quickly go over D as well?
Okay, so D is just asking what type of constraint this is. So we said that this one is an XOR, right? The 3 times x1 plus x3, x7, and x8. It's exclusive OR, right? We can't have, I erased it. We can't have x1 and those other 3. So that's what kind of constraint it is. The next one is, at least, or k of n. And at most is another type of k of n. But it's just at least versus at most. And then this one is a co-requisite, right? You have to have 1, 4, and 9 together. All right, this is problem 5, as you can see, it's straight out of your book. Yes?
Just a quick question about the last one. Are those 3 the only 3?
No, there's a 4th one. Do you remember what that is? So there's k of n, there's co-requisite, there's exclusive OR. What's that? Conditional, very good. Right? That I can only have this one if I have this one, this other one. The difference between that and co-requisite is that co-requisite requires them all, both or neither. The conditional says, if I have that first one, then I'm allowed to have that second one. If I don't have the first one, I can't have the second one. But I can have the first one alone. Which is the difference between the conditional and the co-requisite. Co-requisite says I can't have it alone. They have to either both be there or neither be there. That's the difference between the two. All right, so this one is straight out of your textbook. All right, so it's the multi-goal solution. So you have goal 1, goal 2, and goal 3 here. And so provide the equations of each goal. Right? So what you're going to do is you're going to have the 350 hours, all right, is going to be the right-hand side. That's the goal that you're doing. There'll be something that we compute for that 350 hours, and then there's the differential, right? So this is, what is this? This is for labor, so I'll do this. If we go below our labor goal, or we go above our labor goal, right? So we have our new variables that we've added for these. And so then all you have to do is compute how do you do your labor hours. So I'm going to do product 1 and product 2 are our variables. We're trying to figure out how much of each product to produce. And our labor hours are, if we make product 1 for department A, we do 1 hour, and we have 1 hour for product 2. So it's just P1 plus P2 right there. And then for goal 2, we have the same kind of thing. We have 1,000 hours here. I'll make this A so to differentiate. And now we compute how much it takes to do labor for department B. And it's 2 hours for product 1, 5 hours for product 2. So we get 2 hours for product 1 plus 5 hours of product 2 right there. And then finally, goal 3, we want to have a profit of at least 1,300. So now we look at our profit, so I'll call that profit. And now we just figure out how much our profit is for each one of those. It's $4 for product 1, $2 for product 2. So $4 for product 1. Was it $2 for product 2? So those are our goal equations right there. So now we have these goals, we pick some priority, right? And in this case, goal 1 and goal 2 are priority 1 goals. So what should be the objective that we are trying to achieve? For goal 1, what do we care about? Do we care if we go over our hours or under our hours? Yes, which one do we care about? We care about going over, right? So we care about this value here, right? The same is true for department B, right? We care about going over. What do we want to do with those two values? We want to minimize them. So in that case, it would be minimize DA plus DB plus. Because they are of equal priority. So if we can meet those top priority goals, what will be the values of the variables in that first part? What will be the values of DA plus and DB plus if we can meet our goal? They should be 0, right? Because that indicates that we haven't gone over our hourly limit. And then what do we do if we are able to do that? How do we lock in quotes there, those first two goals?